Okay, so there is a wealth of topics I'd like to address. This will probably be not a purely mathematical video because there have been some things accumulating in the later time, and I got thinking about many things, and they are all just as important as mathematical ingredients because those things, well, because we can't forget that mathematics is done by humans. It is not done by some perfect beings, by which the categories in which they think are just determined per se, but it is done by humans whose categories of thinking of objects are rather arbitrary. And we'd like to take a look at some glimpse of this arbitrariness, but the topic will get much broader because I'd like to connect this general broadness of the possibilities of applications of this thinking of arbitrariness to some other subjects that involve kind of how humans are related to their own understanding of phenomenon of intelligence and of phenomenon of thinking. Wow, that's kind of the outline, but it is not a structural outline, but rather an outline like a window in what I'll be trying to talk about. There's a huge wealth of topics, as I said, and I don't know how exactly I will structure that. But recently I got this impulse of wanting to structure things properly and to take things seriously. Mathematical videos as well as reflectional videos alike. Okay, well, first of all, I'd like to point out some weird difference that persists between me talking while knowing that I have to talk in order to explain something to someone, and between me talking when I talk explaining something to myself. The difference is not just given in terms of the requirements imposed on the way I talk. It's not the only difference. The difference is also given in an immediate feeling of how I perceive my own intelligence and my own capabilities in the moments of the talk. It's like when I'm explaining something for someone, my thinking slows down generally, and I just can't focus properly on things on which I could focus when doing it for myself without any trouble. And that is weird. This is just one example of how psychology that is basically uncontrollable by us, silently affects our performance by certain deeds which we are generally rather not used to. So usually it's such deeds which we are rather not used, right? Because with time there comes this adaptability of the consciousness, and I think by me it also set in now. I'm beginning to find ways how to make my thinking sound even though I'm presenting this thinking to someone. not just in mathematical areas, but generally. But yeah, there is the psychological factor, which is here is a factor of missing habit, or you could interpret this factor like this. And this is important to think about it. Okay, what I also would like to talk about is the modern people compared to the people of the past. There is this more or less commonly shared notion among a certain group of people that our intelligence is on a declining slope, right? Our intelligence as human beings, that the youth is much less educated on average than it has used to be in the past, and similar criticism that can be justly or unjustly addressed to how the modern time influences the trends in development of intelligence of human beings. I'm also one of the people who uh, impose harsh criticism on how modern dynamics affect the intelligence and especially the framework of possibilities to establish own intelligence of people or for people. But I also see, on the other hand, being myself a representative of uh, young generations, I also see the other side, and I see the other side very clearly of what intelligence in the standards meaning is getting replaced by. And what it is getting replaced by is, even though others might contradict me in the beginning, is not necessarily a negative phenomenon. And of course, I should make here a remark that I'm aware that there are still intelligent people, that the level of education generally rises. But here, another remark, there are intelligent people doesn't say anything about the percentage of those people. It doesn't say also anything about the um, objectivity of asserting their intelligence compared to beliefs about what intelligence is. So, about their intelligence used in practical context. And also, what did I talk about? Right. Wow, I have lost it. Okay, I have lost the thread that I was following. Yeah, this intelligence is getting replaced by something, and it is not necessarily a bad thing. And you can see, for example, this getting lost. But uh, I will talk about those features that seem negative, but also have another side. So estimations of intelligence and of trends of development of intelligence are subjected to many factors of modeling, and they are subject to personal interpretations. That's what I wanted to talk about at this point, among other. And the intelligence that is commonly named, that is not necessarily all the intelligence that there is. Of course, you know, this emotional intelligence and things like that. So other types of intelligence, there were probably 5 types if I remember it right, but I'm not quite talking about that. I'm talking about types of a mind having been shaped or being shaped. There are certain types of how minds can be shaped that we commonly standardly regard as minds having been shaped as intelligent minds. And having been shaped can also uh, include inborn characteristics, of course. I mean, having been shaped in a very general sense. So, what shape they attained or are attaining in every moment of time, things like that. Okay, and we kind of concentrate our notions of intelligence on certain types of minds and certain types of being shaped for minds. But we neglect some features which we cannot, by our common notion of intelligence as purely logical intelligence of precise and high capacitive thinking, we neglect some features which can be useful or actually are useful for pursuits of intelligence, but which can be comprehended only much more hard than the features that we usually assume to constitute the intelligence of a human being. And you probably noticing that, for example, I shape my speech in a very general abstract way, preferring circumventing concrete formulations. And someone could say that I am just talking water without having any substance in it at all. But this is one feature of intelligence that might be often neglected. Uh, a human mind could be inclined to think in more general and less general concepts. By that, I'm not talking about things like, for example, having an aptitude to mathematical thinking or having an aptitude to learning mathematics and having joy in learning mathematics, because mathematics is the best example, we go to example for abstract things, right? I'm not talking about that. I'm even claiming that even doing mathematics does not necessarily imply that your thinking is inclined to generalities. What I'm talking about is a much deeper thing that you can observe only as kind of a statistical assessment or on emotional level as a feeling from a person. You can observe whether they are inclined, whether they have this need to circumvent all the concrete details in favor of a description that is much more broadly applicable. And when a mind exhibits the characteristics of generally being inclined to very generalistic descriptions and being uncomfortable with particularities, then that need not be bad. Okay, because it is such minds that invoke, or at least in prospect, it is such minds that invoke the general theories that serve as a framework for everything else that is given there. And the modern people are much more apt when they go this way They are much more apt. Those modern people whom you would consider non-intelligent, non-organized, and things like that, they are much more apt compared to former generations, that is my claim, to having this aptitude to generalistic thinking. This is to a large part, or at least how I see, this is to a large part based on their upbringing happening in a world of open borders for mind, in the world of where things are uncertain and constantly changing, in the world where the variants of how to shape every moment of your life are very abundant, much more abundant than the variants of activities, the available variants of activities of people of the past. Right? This procures this kind of inclination to general thinking. And people whom you might count down because they are rather struggling with concrete things. And what concrete means is depending on the person. For someone, even mathematical abstractions could be too concrete, meaning that as soon as there is an appeal to everyday intuition instead of an appeal to abstract structures developed formally, the person gets lost because they need the total formal framework for everything. And only then they can accept the world of mind that is shown to them. That is just one particular example. As I have already mentioned, my mind is generally inclined to generalities, but that's not all. As I have already mentioned, it is also inclined to automatically perceiving multivariant structure of how the thoughts that I articulate could be shaped in different ways. So much so that I get lost in those variants because I'm automatically trying to follow all those ways of shaping the thoughts at once. So I kind of see a plane instead of a line when I'm thinking about something. I'm not seeing it, but generally people would see a tree with branches, and I kind of see a plane there. But okay, I'm just taking myself as an example of an individual who possesses a rather weird type of features of mind that are, in my own opinion, not necessarily useless and not necessarily a disadvantage compared to features of mind that could be possessed by persons whom you rather count intelligent or more intelligent. Okay, but I'm really talking about myself only as a particular example because I know myself best, and so I can take myself as example for such a person. But I am just a mere fraction of what generally persists in this regard on Earth currently. So the point I'm trying to make, the modern development does not necessarily produce minds that are automatically less intelligent in how they deal with this world and how they deal with challenges of intellectual nature. It is just that the way of how this intelligence works shifts. It is shifting in certain directions that I try to describe with examples and general descriptions. Okay, and I told you that I intended not only talk about mathematical topics in this video, but actually main topic of this video is mathematical. And this was kind of an introduction, and now I'd like to demonstrate you one particular example of what minds of the new type, let's call them like that, not better, not worse, just minds of the new type. If it is better, worse, or something, that is to assess by the beholder, and beholders could be different people, right? All right. The minds of the new types are capable of something which is just qualitatively different. But at this point, because I have to always talk about it, I should also mention that I'm not exactly the best representative to show the intelligence of the new types of minds. Not at all, because I have my own cognitive deficits that I perceive. And again, here I should mention that yes, it is partly, or it is with a huge probability to assume that some modern trends encourage this kind of cognitive deficits. I'm talking first of all about the connection to the fast-lived world of digital life. It is some features of the digital world, maybe I'll make a video about it, that make human psychology work differently, and they affect it negatively. If a human doesn't have a firm foundation like the humans who, like the people who uh, went over into this time from the former decades, if a human doesn't have this firm foundation in himself, this firm foundation on thinking, and this firm foundation of own will, then those trends can definitely affect people negatively. But it's not the only the effect, and that I tried to cover in the first part until now, right? But I have also to mention that there are those negative effects, and they are exhibited in me rather strongly. So I am not exactly a great example for that. But the curious thing is, even though I am not exactly the brightest person, generally, anywhere, despite that, because of those new features of mind, I can see things that seem concealed from other people. And in particular, I can see such things in mathematics. And it's not that I can see them, that's actually wrongly phrased. I must see them, because when I'm trying to get in touch with a topic deeply in my mind and in my intuition, like I wanted to teach this course on calculus 1, and I started to think about topic about the topic very deeply, then I just bump into things that are not done properly, and they are not done properly on a very foundational level that constitutes what one is actually doing, where one starts, where we start mathematics. And I'd like to demonstrate you now that the axiom system on which the modern mathematics is based does not actually admit a certain definition of set that is very widely used. A definition of a certain set, I should say, rather. And this is like very simple issues. It doesn't interest anyone, but like when I tried to develop an explanation for other people of those concepts, I just bumped into it and I tried to develop it and tried to develop it in one way, in another way. And then it became clear there is a need for an additional axiom. This axiom is the iterational axiom. Okay, we'll talk about the natural numbers. The most natural thing in the world, the thing by which we could begin our very first mathematics courses at the university, right? I'm assuming some awareness of listeners with some mathematical frameworks, so I directly go to the axiomatic construction to the nature of the natural numbers, right? In the most axiomatic, most basic construction of the natural numbers, we are doing that, right? This is how we define them. Actually, I should rather don't make a correspondence, I should make a definition. So this is an interpretation or definition, and so we define the natural numbers, right? Okay, this is how we define them, and we go on, right? Now, now I'd like to try to be very precise because I'd like to convey to you exactly what the issue is. Now you could say the set is defined as the set of natural numbers. Let's think about it a little bit more. We can write that down. There's no problem. We can then write that down. There's no problem. We can then write that down. There's no problem. We can then write that down. There's no problem. We can really, and here I mean it in exactly the way like I stated, writing down everything in between until n symbols of occur within notation. That is what is happening here. What's happening here, writing down everything in between until n symbol. And imagine we have written that down. I have not written those dots. I just write that I just write dots to not really write it down, but actually I should have written that down completely explicitly. So here goes parenthesis, here goes a parenthesis, and so on, and exactly like that, right? Okay, imagine I have written that down concretely. There is no problem, I can do that, right? But now, if you'd like to talk about writing that down for any n, or for any number of operations, then you are basically saying in mathematics, and I mean in terms of the ZFC or any other TF or whatever, it is allowed to define objects in the way of considering extrapolation results of a stepwise iteration. And by extrapolation, I mean we have only written it down. We can only write it down for a certain number of those objects involved, right? We can physically only write it down for that, and so the things that we can write down only those. Okay. In math, it is allowed to define objects in the way of considering separation results of a stepwise iteration as referring referring to define objects as referring to the results of all such potentially possible step sequences. And by potentially possible, I mean, of course, this is one potentially possible sequence. Sequence is finished. This is another potentially possible sequence. Sequence is finished, and so on. Okay, when we take all such potentially possible sequences of doing exactly that, of taking the previous, writing the parentheses about it, and taking it as together with another empty set, right, from here to here. We can do this one step always, and we can even assume, like by piano axioms, this step can be done. But no axiom at all allows to define an object that takes all those finite iteration results at once because it doesn't matter what axiom you use. It doesn't matter at all. If you take piano, you might think you can circumvent that issue, that I'm inventing something. Then you have the successor, and you have the induction axiom. But in whatever way you would try to define an object, a set, that contains that is the successor function, right? That contains all those, you could never say that this set is in any way allowed to be, because you have no way of specifying it at all with the axiom that you have, with the axioms that you have given. You might try it somehow by induction, that this is represented that way, this is represented that way, but you can't define what it means to be represented in that way. Like, oh, plus is of course a successor, doesn't matter. You cannot define that. You don't have it yet. And you could try, I don't know, something like the natural numbers are the union. Of course, the customarily thing would be just to define that it is the union of all sets of shape. I don't even know how to denote that. Like, of course, you can't use natural numbers. This is another point. You might be tempting to use natural numbers here for counting. But you cannot use natural numbers for counting until you have defined them. Because counting with natural numbers, or counting in general, can only be defined logically after you have introduced natural numbers in their familiar shape, right? In their familiar shape, meaning that it actually produces this notion of counting. We define that as having 1, we define that as having 2. So we define the number of steps that we have to go to cover all of them. But again, number of steps. Okay, let's use language. We can talk about number of steps. But mathematically, we have only defined number of steps after we have this set. Otherwise, it is not given. So you are not allowed to use natural numbers here. But okay, you might circumvent that you just say all sets that are defined for seizing step iteration of, that is, the step iteration seizes somewhere, right? For step iteration of, and you might define that as natural numbers. All sets of those that are defined for seizing step iteration of course, you mean the union of the products of the yieldings of that step iteration. But you can't even define what all those step iterations are, unless here you can't use any axiom to say what seizing is. You cannot talk about seizing step iterations, because seizing means finite, and finite would be bijectively equivalent, so equivalent in cardinality to a subset of natural numbers that is not bijectively that is not bijectively mappable to the natural numbers, right? So you don't even have seizing. And any way that you might suggest for defining this set of natural numbers using the usual axiom systems, it can't work. It won't work, because you will always need this notion of axiomatically allowing for iteration, of axiomatically allowing for sets defined by any potential iteration. And this makes obvious that there is need for new axiom, need for a new basic axiom in it. a new basic axiom, the iteration axiom. And what I will talk about that in my course because I want to have it all solid. I want to have it all derived from axioms. But the need for a new axiom is probably apparent because there's no way to define natural numbers based on the axiomatic systems. There is just no axiom that allows the things that we just do. Oh, like it goes. It just goes. This set cannot be defined based on known axiom systems. There is a need for new axiom, the iteration axiom. And the variance of iteration axiom that I would like to define natural numbers coming from real numbers. Yeah, I should mention that. To define natural numbers, it does not suffice to give a standard definition of them. To actually use them for counting, so for all stuff like sigma product, sigma sum, sigma union, and things like that, you have to know that they have such shape. So to define natural numbers, meaning establishing this shape, is only possible if you have the iteration axiom. Of course, you might say like, well, we established that between two natural numbers, like or by the definition that is coming from the reals, you can establish that between two natural numbers, meaning that interval you have only this empty set. I mean, you can establish it axiomatically by axiomatically defining the real numbers. You can do that, right? But again, you would have to have, if you are doing that, you cannot establish that every natural number only arises in that way. You could only go that far. You could only go until some n, and until some n means you write it down, you use that, you write it down, you use that, you write it down, you use that. And you might begin tempted to say induction. Wow, induction would tell you about all natural numbers that that they can be written in terms of, okay, let's do induction, like we have that and then we have to know that the n plus 1 is also written as sum of ones. And then you would say, well, plus 1. Actually, that might work. That just might work. That just might work. I'm not sure yet if there is an issue. Maybe there is none. Maybe that really works. This definition for natural numbers really works. As I said, I mean, we define it based on real numbers as an intersection of all sets having inductive property. When we have that a natural number, we have that a natural number, for example, 1 is represented as a sum of ones, right? And then we just say, well, each natural number is represented as sum of ones. Okay. You see, seemingly we are now done with this issue. But in truth, this issue just hit itself behind term sum of ones, because we have, okay, when we are assuming that we can use this term, then what we are actually assuming, we are assuming that we can have an iteration which goes like that and produces an object, right? That produces an object that we recognize as mathematical object. But we are not just talking about one iteration with a certain number of times, where a number we can only specify in writing down exactly what we are doing. So we are allowed to do that. We are allowed to do to write down, of course. What we are talking about is generally a notion of a sum of ones. But please try to define this notion. Try to define the notion sum of ones. You cannot, because you have to introduce the possibility of defining a mathematical object via iterations. Only that your iterations now are not some things that are defined, but rather the operation of the real numbers is defined. And now you are applying the iterational axiom, or in truth, you are applying the iterational axiom to the iteration of plus. You are not iterating a procedure of definition, you are iterating a procedure of application. But again, if you want to have it for all variants, then you have to assume any sum of ones and this is the emphasis. Any sum of ones at once is a defined mathematical object. But if you just say any sum of ones, what you really mean, you mean for each sum of ones, you either have a notion of sum of ones as an iterative infinite procedure in itself. If you have that notion, then you have already internalized the iteration axiom, but nonetheless, mathematically, you would need the iteration axiom. Why? Because you could never specify a set sum of ones. There is no axiom that allows you to specify the set. That's again same thing. So only that now we have found a circumvention, and maybe there are even more sophisticated circumventions where you would not say it directly, but it is all just purely rhetorical avoidance of the actual issue. Okay, so you can't talk about any sum of ones. Of course, you could say this mathematical axiom is purely intuitional. We know that you can just have it for what? For each natural number. So if you want to stay mathematical, in the sense of establishing every part of the foundation that we actually use in our thinking, then there is a need for new axiom. Even here, though I was confused for a minute there myself, maybe it works, but no, it doesn't work, because here I employ that. I employ sums of ones in a general sense to just formulate. To use the induction, we need to formulate the statement, right? If we are completely rigorous, completely precise, we need to formulate a statement. And so that we need each natural number can be represented as sum of ones. But what is this object, general sum of ones? So this is a circle. This again runs into the definition of natural numbers. Oh, well, definition of natural numbers is really iteration. It's nothing else. But iteration has to be defined axiomatically. And I think it can be proved. It can be, the independence can be proved that all such objects actually constitute a thing without each the any axiom system is consistent and with which it is also consistent. Okay. Iteration has to be defined axiomatically. Okay, and this is basically the big thing about which I wanted to talk because in our next calculus video, and that video I probably will prepare because I have run into this issue, I will state and like define the things around the iterational axiom. I will state the iterational axiom and I will explain what it is, how it works, and things like that. But yeah, it will be a rather peculiar thing, kind of similar to the axiom of choice or something, maybe even weirder. I don't know. But yeah, iteration has to be defined axiomatically. And there are like issues. I don't know if I will address them. I don't know if I will investigate them. I don't know if I will do a full account. But yeah, I already wanted to make this video among other because in my opinion the iterational axiom when added to real numbers it is quite, it's not, I can imagine that it's not necessarily easy to get used to it. Okay, but we have to do that because we can't just take natural numbers and begin to use them for sigma notations and things like that just without even saying what we are actually doing. And we can only say that in terms of axioms because it can't be derived from anything as effectively demonstrated. And you can give me any establishing of natural numbers and I will show you that you can't do that without an additional axiom. Okay, this has been my take. And next up, definition of natural numbers. Use of newly introduced with partial use. Because we'll use the iterational axiom to establish this set, to establish this shape of natural numbers. To establish that they really go like that. Definition of natural numbers with use of the newly introduced, of a partial use of a newly introduced iterational axiom. And I should warn you about that if you are following this course. I mean, okay, this video is not necessary, but okay, that's just my style. Iterational axiom. That I like mix up things in course and psychological things and things like that. I should warn you that iterational axiom is not actually something, as far as I know, that is taught in courses or even in mathematics. It's just my invention now. I saw the need for that and I will add it because, in my opinion, maybe I'll get disproved with that, but in my opinion, there's a need for this axiom. There's otherwise there's no way to define natural numbers in a proper way. And maybe someone can prove that the iterational axiom is independent, but I guess it's also, I think it's at least conceptually, no, not formally. The proof is not that hard. Iterational axiom has to be independent of the ZFC or whatever axiomatic system that we use usually. It has to be. So I claim it. Okay. Oh, but yeah, be warned that it is completely my thing. I'm kind of, well, a little bit creating my mathematics because I personally see a need for that, and maybe, well, maybe other people will agree when they look at it and think about it clearly. I think so. I'm on cover. Definition or establishing the shape. Establishing the shape. Okay, so that's what I like to talk about, and with that I finish.